Good evening, my dear students and friends. Myself, Dr. Ravi Kant Pathak, and I'm going to start your video lecture class. In the last video lecture, I have discussed about the tubular secretion. In this video lecture, we will talk about the next topic, and the name of topic is the counter current mechanism or mechanism of the concentrate filtrate. Okay, so what is the tubular secretion? This is the third step. Tubular secretion is the third steps of the formation of urine. You know very well. So there is the three different steps generally found. So first is the glomerular filtration, second is the reabsorption, and third is the tubular secretion. In the last video lecture, I have discussed about the third step, which is known as the tubular secretion. And now today I am going to talk new topic. The name of topic is the counter current mechanism or mechanism of the concentrate of filtrate. You can see here what is means of the counter current mechanism, because here you are seeing this figure. So there is the limb loop of Henle, means loop of Henle. There is the descending and this is the ascending limb loop of Henle. So this is running here from urine is moving like this, and there is an this is the limb of loop of Henle, and similar to limb loop of Henle, there is one peritubular, there is the one blood capillary which is known as the Vasa recta. This also runs parallel to the limb loop of Henle. So they form a counter, they act as a counter mechanism. So that's why they have given the name counter current. Why? Because one is moving in this direction, and in case of the Vasa recta, so that is blood also flow in this direction. So that means there is the counter current. So there is the formation of counter current. So that's why they have given the counter current mechanism or mechanism of the concentrate of filtrate. Why we are saying concentrate of filtrate? Because this counter current mechanism involves formation of the concentrated urine. This involves in the formation of concentrated urine. The Henle's loop and Vasa recta play a significant role in this mechanism. So it is saying here, limb loop of Henle's loop and Vasa recta both are play important role. Henle's loop you are seeing here. This is the you know very well. So there is the glomerulus region, then PCT, then limbal, then Henle's loop after DCT, then collecting duct. This is the different parts of the nephron, in which Henle's loop generally located inside the some region there, total nephron, some region located in the cortical region, and some located in the medulla region. Okay, so now you can see here the Henle's loop. So this is the figure for Henle's loop and Vasa recta. Vasa recta I had already told. What is the Vasa recta? Vasa recta is the nothing. This is the formation, or this is the blood vessel or blood capillaries arise from the peritubular capillaries, and they runs parallelly to the limb loop of Henle, but in opposite direction. There is the it will run in the opposite direction of the filtrate. Okay, so this is the parallel to the limb loop of Henle, and this derived from the peritubular capillaries. They have already asked one time in NEET exam. So Vasa recta generally derived from. So it is derived from the peritubular capillary, and peritubular capillary this also forms from the afferent arteriole. You have to see in case of the glomerulus filtration, glomerulus region. So there is the two different arteriole runs, one which brings the blood from different body parts and open into this glomerulus region, that is called efferent arteriole, which is the thick, and thick means they have the much diameter, and another is the efferent arteriole where is the less diameter, which brings away blood from the glomerulus filtration region, and this efferent arteriole forms the peritubular capillaries. Okay, so now this is the figure you can see in this limbo loop of Henle. Here 300 milliosmolarity of the urine, and here 600 milliosmolarity, and here 900, here 1200. If you'll move from top to bottom, if you move from top to bottom, in case of the descending limb loop of Henle, what is happening here? Here you can see the concentration continue increasing. Why? Because this is permeable to water molecules. Water molecules they can easily move outside, means they can easily come into the interstitium fluid, and when the water will lose, so after that their concentration will increase. So same thing happening here, but after that you will see here u-shaped limb loop of Henle. When you will move in case of the ascending loop of Henle, ascending loop of Henle, this is the thick. So here concentration, then ulcer concentration becomes going to down. Why? Because here this ascending limb loop of Henle, it is permeable to the sodium chloride molecules, means NaCl molecules. It can actively comes inside the interstitium fluid. So that's why here concentration going to down, means their concentration continue decreasing because sodium chloride molecules comes inside the interstitium fluid. So these things happening in case of the limbs loop of a limb. They have given, and this is not impermeable to water and solids molecules. They have already given. It is impermeable to water and solids molecules. So that's why here sodium means you can say sodium chloride molecules is going to outside and the concentration continue rising. Okay. Now you can see in the next slide what is have given here. In the next slide, the flow of filtrate in the two limbs loop of LA in opposite direction and flow of blood through the two limbs of the Vasa recta is also opposite direction play important role in establishment of the counter current mechanism. What is saying here, you can read the flow of filtrate. If you see the flow of filtrate in the two limbs of loop, the flow of filtrate in the two limbs Henle's loop in opposite. So means one limbs here also and another is here. So the two limbs in the two limbs of Henle's loop in opposite direction. So here you can see this is the opposite direction, and the flow of blood through the two limbs of Vasa recta. Here you can say I am drawing the figure. This is the suppose that this is the Vasa recta. I had already told this is the blood capillaries which is only runs parallel to the limbs loop of Henle, but flow of but flow of blood is opposite direction. So here they have been opposite direction and flow of blood through the two limbs of Vasa recta in also in opposite direction. And due to this, if you see here, I'm going to change the color so you can easily understand. So here you can say this is the movement of filtration here in this direction, and in case of this Vasa recta, the movement of filtration in this direction. So they form the counter, they establish the counter current mechanism by which the concentrated urine will form. Next, what is explaining, you can see the proximity between the Henle's loop and Vasa recta help in maintaining and increasing the osmolarity towards the inner medullary interstitium. What is saying the proximity between the Vasa recta, because if you see, so there is the Vasa recta as well as limb loop of Henle, they are very close to each other. That's why they are able to maintain the increasing osmolarity towards the inner medullary interstitium fluid. Why? Because here you can see this, suppose that in this figure this is the Vasa recta. Vasa recta means VR. I'm here representing Vasa recta, and this is the eye of interstitial fluid. This is the interstitial fluid, or you simply you can say medullary interstitial fluid, and this is the limb loop of Henle, you know very well. So what will happen when the urine will move down? So water will comes into the interstitial fluid, and these water where will enter? These water enters inside the Vasa recta. You will see in the next figure, then you can easily understand. So there is the one. If you move into the limb loop of Henle, the concentration continue is increasing. Okay. Now, here you can see, so it is saying the proximity between Henle's loop and Vasa recta helps in maintaining and increasing the osmolarity towards the inner medullary interstitium. That is from 300 milliosmolarity in the cortex. This is you know very well. So some part of the nephron up to the cortex region. So there is the there is concentration very less, but if we'll move from top to bottom in ascending limb loop of LA, so what will happen? The concentration continue rising. So here you can say 300 milliosmolarity in the cortex to about 1200 milliosmolarity in the inner medulla region. So this is the inner medulla region. So there is the concentration continue rising. It will move from top to bottom in case of the limb loop of as descending limb loop of LA. So this have given, and these play important role to establish the counter current mechanism. Okay. So now here in this figure, this is only representing. If you see, it have given 300, 600, 900, 1200 milliosmolarity of the urine. Okay. Now next, you can see what is they have given. Which substance play important role to maintenance of this counter current mechanism? So there is the two substance play important role. First, you can see NaCl and another is the urea. So they have given this gradient. This gradient is maintained or mainly caused by the NaCl and urea. NaCl is transported by the ascending limb loop of Henle. You have to see in the previous figure. So there is the NaCl and NaCl how transported? It is the actively transport. Actively transport means there is the movement of the molecule against the concentration gradient and it requires the energy. So here the NaCl molecules is the actively transported by the ascending limb loop of Henle, which is the exchanged with the help of with the descending limb of Vasa recta. You can see this is the Vasa recta here, this figure. You can see this is the Vasa recta and this is the descending and ascending limb loop of Henle. This generally runs parallelly to limb loop of Henle. Now you can see here NaCl molecules generally comes outside, means it generally comes interstitium fluid. These NaCl molecules, you will see here these NaCl molecules, where it will enter? It will enter into the Vasa recta, and when it will enter into the Vasa recta, what will happen? The concentration of filtrate in Vasa recta, uh, not Vasa recta, filtrate, you can say blood. So the concentration of blood in the Vasa recta increasing. Okay, so the concentration of blood Vasa recta increasing. Why? Because NaCl, sodium chloride molecules, is entering inside the Vasa recta. Okay. Now here they have given the NaCl entry, and this is in case, because here this is the limb loop of Henle. Just opposite, you can see in case of the, this is the descending limb loop of Henle, and here it is the ascending limb loop of Vasa recta. Okay, and these Vasa recta, here water is comes outside, and these water where it will enter? These water enters here, and what will happen? The concentration continue decreasing. Here Vasa recta means both Vasa recta and limb loop of Henle both play important role to maintain or establish the counter current mechanism or formation of the concentration of filtrate. Okay. Now NaCl is returned to the interstitium by the ascending portion of the Vasa recta. You can see in this figure, this is the clearly explaining. If you are understanding, so that means very good. You can see here, this NaCl comes inside the interstitial fluid. This interstitial fluid, the NaCl further where enters? It will enters into the descending. You can see this is the uh, ascending portion. They have been the NaCl returned to the interstitium by the ascending portion of the Vasa recta, means they further enters into the ascending portion of the Vasa recta. Okay, so here they have given. Now you can see this is the similarly to the uh, that means they are parallel. So this is ascending limb loop of ascending limb of Vasa recta, and this is the descending limb Vasa recta. If you see, so there is the here filtrate is moving in this direction, and the blood moving in this direction. In case of the Vasa recta, they establish the counter current mechanism. Okay. Now, you can see in the next figure, so this is the clearly explained next figure, which is the clearly explained. Same thing also have given. What is saying? Similarly, here similarly small amounts of the urea. I had already told two things play important role. First is the NaCl and another is the urea. So small amounts of urea enter the thin segment of the ascending limb of Henle's loop. You can see this is the ascending limb loop of Henle's, and here urea how enters, because this is the collecting duct. These collecting ducts, they generally release, here you can say this figure showing the urea. This urea comes into interstitium fluid and it further enters into the ascending limb loop of Henle. So this I have given, and which is transported back to the interstitium by the collecting tubule. So they have given, from the collecting tubules it transported back into the interstitium fluid, and from the interstitium fluid it enters into the ascending limb loop of Henle. And this mechanism helps to maintain a concentration gradient in the medullary interstitium. So that's why here NaCl also releasing here, and urea also releasing. So due to this, they have maintained the concentration gradient. And presence of such interstitial gradient helps in an easy. What is saying, you can see, just I am going to remove because there is the large number of the numerous underlines. So that's why you can't differentiate. But now, right now we are going to again doing. So presence of such interstitial gradient helps in easy passes of water from the collecting tubules. It is saying presence of such interstitial gradient means inside, in case of the ascending limb loop of LA and collecting duct. So there is the formation of the interstitial gradients and it helps an easy passes of the water. That's why here water can be easily passed from the ascending limb loop of Henle into the collecting duct, water from the collecting tubules, and thereby concentrating the filtrate. And here what will happen, the water will move, means filtrate will move, and here filtrate will move. This filtrate become much concentrated. Here water also comes outside, urea also comes outside. The urine will release in the form of highly concentrated, means you can say here urine release in the form of concentrated. So that's why here they have given about the counter current mechanism. So counter current mechanism is the very important to establishment of the uh, or formation of the concentrated urine. And here we have to study, there is the two things, Vasa recta as well as limb loop of Henle play important role. And I'm going to represent the one more next figure, which is clearly explain your concept about the counter current mechanism. That is the wonderful and very good pictures which explain clearly, because you can see here similarly the Vasa recta as well as limb loop of Henle, here they have given. So before I am going to discuss, you should to make the basic concept. What is the basic concept? This is the limb of loop of Henle. This is LOH, and this is the uh, okay, just wait, what it have given 300, yes. So limb loop of Henle, and here they have given the Vasa recta. So this is the VR Vasa recta. Clear? So you should make this concept. So here they have given the limb loop of Henle, and here it is the Vasa recta. Okay, now you can see. In case of the Vasa recta, in case of the limb of loop of Henle, this is the descending limb loop of Henle, and you know this is the permeable for water and impermeable for salt and another molecule. What will happen when water is comes into the interstitium fluid? This is IF, you can say interstitium fluid. In this figure, I had already told it is the very good, and they depicts everything about the formation of the concentrated filtrate or urine. This is the clearly explained. It is the IF, this is the loop of LA, this is the Vasa recta. Now, this loop of LA here, what is happening? The water molecules comes inside the interstitial fluid, and when water molecules come inside the interstitial fluid, the concentration of the filtrate is going to rise. Here you can say in this when you will move from top to bottom, the concentration is going to rise, and here 1200 milliosmolarity is going on. Okay, and after that what will happen, this water where is going, this water comes from the uh, descending limb loop of LA and uh, enters into the descending limb of the Vasa recta, because this is the similar, both are there. I had already told Vasa recta is the nothing, this is the blood capillaries which forms from the peritubular capillaries, and it runs parallel to the limb loop of LA and maintains the counter current mechanism. Now here 1200 millimosmolarity. And when you will move from another limb loop of Henle, which is known as the ascending limb loop of Henle, what is happening? This is the permeable. It is the permeable for the sodium chloride molecule. How it is the actively transported but is impermeable to the another molecules. So that's why what happens, sodium chloride is going to outside. When sodium chloride molecules is going to outside, and this is permeable for water molecules, water can enter. So what will happen here? The osmolarity continue decreasing. So here 900, then here 600, here then 100 milliosmolarity. Why? Because sodium chloride molecules come into the interstitium fluid act via actively transport. Okay, so here they are. When sodium chloride molecules come inside the IF, that is the interstitial fluid. Okay, so this is the story about the limb loop of Henle. Now we will see here what is the Vasa recta. So just inverse display important role. Here you can see just inverse. You will see here 100 milliosmolarity and here 300 milliosmolarity. And this is the blood here blood filtrate. Here they win. So this blood things, you will see in case of the ascending limb loop of Henle, there is the concentration up. If we move from bottom to top is down is decreasing. But if we move from here in case of the Vasa recta, so there is the uh, top to bottom it is increasing. Why? Because this sodium chloride molecules comes from interstitial fluid into the ascending limbs loop of ascending limbs of the Vasa recta. So now here sodium chloride molecules comes inside, and when the sodium chloride molecules comes inside the Vasa recta, the concentration will rise. Here concentration will rise. Okay, and if we'll move from in the ascending, this is the descending. So descending limbs of the Vasa recta. So there is the water molecules. This water molecules where it comes from the interstitial fluid and enters into the ascending limb of, sorry, descending. This is the, I have to already told, this is the similar to the limb loop of Henle. This is the descending limb loop of Henle. This is the descending Vasa recta. This is the ascending limb loop of Henle. This is the ascending Vasa recta. Now, so these descending Vasa recta, so these have given the descending Vasa recta. Here the water will move from the descending limb loop of Henle and comes into the interstitial fluid, and from the interstitial fluid comes inside the descending limb loop, descending limb of the Vasa recta. So what will happen when the water will come inside, the concentration continue decreasing. So here concentration is continue going to decrease, and here concentration. So that's why both are the counter current. Why we are saying counter current means, you can see here one is in this direction and another is the opposite direction. You will see this blood filtrate moves in this direction and urine filtrate moves in this direction. So that's why they maintain the counter current mechanism. Okay, so this is the very important, and I think it is clearly explaining, and these figures just you can say very good, which explain the every concept related to the counter current mechanism or formation of the concentrate filtrate. Okay, so now I'm going to stop your class, and thank you again for patience, and everyone should share, subscribe and hit the bell icon for regular updates. So thank you again.